Hello, hello.
Hi, Dr. Jeff.
How's everything going?
Uh, I'm trying to get the add-in for the real statistics resource pack, and
For Excel?
for Excel, and I follow the instructions, but when I click on add-in, it doesn't appear. But when I go to tools and
Can
add
you
in, it says that it's checked off.
can you share my screen
Oh, yeah.
or your screen, not my screen?
Yeah,
Sorry.
yeah,
Thank God you understood what I meant.
yeah.
Allow. There you go.
Okay. Can you see my screen?
Not yet. Give it a
Oh,
second. It's still thinking, I think.
I know. Hmm.
Hmm. Why are you not sharing?
Let me see. Let me try again. Share. There. Oh, wow. Okay. Why is it not sharing me? Oh, no, no, it won't share.
Oh, if you don't mind saying after a minute,
Okay,
we can do that. We can
okay.
take a look at it.
Thank
I,
you.
every Zoom is different at every school.
Yeah.
I didn't know why we wouldn't let you share. It doesn't make any sense. Something going on there. Helicopters rolling around everything around here.
Hmm.
Before it was like two or three of them. I don't know where. Yeah,
Oh,
but there was only two.
sometimes they post or they give an announcement like they're looking for somebody. No.
No, we don't get that over here very often.
Oh, that's good.
More like one of the homeless guys is doing something stupid again. We had one of them that got busted early in the morning, let them go, and then the second time they had a big chase and ended up at the store up here, and then ended up over at the park. It was just like, oh, you had him in the morning. Why didn't you just keep him? He was already a mess when you had a hold of him. Let's see. Multiple participants can share simultaneously.
Hmm.
Advanced.
Maybe you can ask any other students if they're having problems.
No, says all participants.
Oh
Multiple.
no, I meant like if they're having problems getting the add in.
Let me start that up.
Hmm.
Oh, I need to start up G Power too. Thank you. Good idea.
Mhm.
I need to go here real quick. Go GG. All right, start up. We got 2 minutes. Okay. Developer add-in. Well, that's weird. It's asking for my Fullerton sign in. I don't know why you would ask for my Fullerton sign in rather than my SDCC. Uh, so when you go to your data, uh, going across home, insert, draw, page layout, formulas, and then go to data. You see it?
Let's see.
It's at the top.
Yeah.
See data,
Yes.
and then you go to the far right. Do you have a one that says data analysis in the very last row?
Yes.
Click on that.
Okay. And it shows me analysis tools.
That's it, right there.
That's it.
Yep. What did I ask you to do to get that?
Um, you asked, well, I watched the video. Um, He said, watch the video, and I watched that, and the guy had us download the analysis tool pack and then
Yeah,
the real statistics resource pack.
right.
But I can't get the resource pack to upload. Like I have it saved onto my
I don't think you
computer,
need, I don't
but
think you
it
need,
doesn't. Oh, I don't need it.
I don't
I
think
hope
you need.
not. I hope not, because I can't get it to work.
Okay. You're really going to use those later unless I decide to make a move, which I may make a move to SPSS and make our lives a little easier.
That would be nice.
I know. Um, I just don't want to make too many people mad my first semester, you know what I mean? All right, welcome everybody. Does anybody have any questions to start?
I just had a quick question, this is Laura, about the t-test discussion. In the, you have us do like several definitions, and then there's two questions.
What
I just
t-test?
wanted to make the t-test discussion where you have us do the different tables. You have us define like a p-value. What
Oh
is the
yeah,
p-value?
that's
Okay.
not a t-test. That's not a t-test. It's a
Okay.
p. So what is your question?
So the wording of question 4 and 5 is what is the significance of wording if the p-value is below 0.05? I just
Mhm.
wanted to understand what are you looking for in that, sir?
One word?
I'm just you're just looking for a word, one
Yeah.
word. Okay.
Does anybody want to help her?
I think the question is just kind of written there, not a lot of clarity.
There's
I
no.
I took it as defining what it means, like if the p-value is above 0.05, and then the next one define what it means, like the significance of the p-value if it's below 0.05.
Mhm.
Okay, that's what I was wondering. It was just the wording of the question that I wanted to
Yeah, I
clarify.
struggle with the wording on that one. I
Yeah, the
will admit
That's
wording's
that,
tough.
okay. Okay, thank you.
but you're on the right track. Anybody else have any questions?
I have some
So,
questions, but I was gonna wait for you to at least go through the demo,
see if I got
and
it.
it might answer them in
Okay.
that.
Um, the first thing I'm going to tell you is that I did my best to go through those numbers and try not to get any duplicates, but there are anytime I made a move with that thing, the numbers changed. So it might have been on the last one that some of you had duplicate numbers. If you do, just grab another one and just go ahead and go for it. So I apologize for that. But yeah, that's the best way because but what you were gonna do was you think the wording was bad on that one. You should have seen the wording that I took out for the other one. It was I had to decipher it, and it's too much work. We don't have enough time for that mess. So we that other class the stuff that's in there is really good, except it just hits the surface, and you need a little more deeper. And this is what this is. So I don't have a lot to. I have a little bit to do tonight, but really it really comes down to when I get to a certain part. If you don't see something, don't understand it, just speak up. Don't be shy because everything is really straightforward. The problem is some of you are making this a lot more difficult on yourself. This is really, do you know how to do it? And kind of and have a relative understanding of it. Because a lot of this stuff, until you do it 12, 13, 14 times, it's not going to make any difference. You're going to be okay at it. But after a little while, you get really good. I'm not gonna lie to you. When I started this process years ago, I wasn't very good. I had a lot of the basics down, but it wasn't until I did it over and over and over again to where now I can take something and look right at it and make great analysis on it and actually make the correct analysis on it. So don't beat yourself up if it doesn't come right away. It's the idea of we're not doing enough repetition to really get it. That's why I put in the Tuesday night gigs. I don't have to do this. I do this because I know what you're going through. And if I can speed up the process, but if you just all sit there and don't ask the questions that you have, or wait till the end and talk to me, well, that's all the same. Some of you have been hitting me up. Don't worry, you're not stressing me out. You're not worried me. Some of you are coming with good things that I made a mistake on. I have no problem. I have no ego. So if it's in your favor, if it's in your favor, if I messed up, either way, it's in your favor. That's the way I roll. It's not something that I gonna browbeat you on. Okay. I'm gonna pick on you. I'm gonna make you try to do my best to make you work a little harder to get it, but you're not gonna be doing a lot of math. You're not gonna be doing a lot of formulas the rest of the way. Uh, Excel is easy, but it's very difficult. When I look at it, I say the same thing. It's difficult. You got to get everything lined up perfectly. SPSS, I don't have to line up perfectly. I get the data in there, press the buttons, and it pops out what I want. Okay. So bear with me. And there may be a change where as I look at this, I'm going, you're not getting what I need you to get, which to be able to analyze numbers and not be really, really good at Excel and then be so done that you don't want to touch it. That's the same way I feel about a formula. So that's my soapbox for tonight. So let's get into the hypotheses portion of this. Okay. So not much to show on this. The problem is some of you like to fluff things up. And you cannot do this in your DNP. Okay. Everything was straightforward. I always look at it as the idea that I walk up to two females that I know very, very well, and one gives me a big hug and a kiss on the cheek, and the other one slaps me in the face. Okay, the one that gave me a kiss and a hug could be saying, "Hey, I love you. This is great." Yada 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 yada. But you don't really know if that's true. She might be somebody that's just really, really nice. The other side of that is the female that slapped me. I know there's something wrong. I know that she has something on her mind that says that I'm mad at you. That's where I need you to always look at your data as you are going to be mad at somebody. It's straightforward. It's right to the point. So I have not graded some of the people that are in there because I want to get through this night and hopefully you'll understand it. So I need somebody to turn on their mic. And if I don't get somebody in comments, I'm going to pick on somebody that's on my screen. So just know somebody better step up. And I don't care if your answer is wrong. I care that you give an answer. So tell me what a hypothesis, somebody tell me what a hypothesis does. What does it do for your study? Go ahead.
Is that like a best educated guess?
Yeah, that's great for a science answer. That's a good science answer. But really, well, if you looked at it, if you've done the pre, what does it really tell us?
Can I answer?
Sure, knock yourself out.
So I wrote it is to show the results and assess of two samples of the data to support the theory.
Another very good one. But it doesn't quite hit what the concept of it is. Those are both correct. So don't let me tell you that you're wrong. It's correct. It's just a little bit. There's a little bit more to it, and I'm going to give one more person a shot.
Is it to do with? Oh, go ahead.
No, go.
There's two people. I'll give you both a chance. Go.
Go ahead, Renee.
Okay, thank you. I wrote a hypothesis is a statement or prediction that is scientifically investigate and determine the relationship between two or more variables.
Okay, we're getting a little closer with the relationship of two variables. Somebody else want to give it a shot? One more person.
So the no is when there's no effect from your intervention.
Oh, you almost had it. You almost had it. It's like you're like right on the edge of the bullseye. What did the video say? What did the stuff I put on there say? I can't remember which class this is if I did that. Okay, the key word there is effect. How, and I'm getting ahead of myself, but if I can give you a visual picture, if you've taken statistics before, there's an independent sample t-test. And that's where you're looking at two things against a variable. against like a demographic. So it's a yes, no question versus a demographic. Okay. How do you come up with an effect in that? Is there a way to come up with an effect in that?
Like a statistical analysis?
Well, yes, but there's no way to really get in that answer. Okay. Because you're looking at an outcome, and we don't look at outcomes. We look at basically little conclusions of that data. You can't measure impact. You can't measure effect. You can in your purpose statement in your research question. Now, when you come here, this is all about the data and only the data. It's not what you're trying to test. So that keyword in there is difference. Okay. And a lot of you put impact. Out of that hypothesis, you're not going to know if there's an impact. So did anybody get far enough to understand when you pick the null and when you pick the alternative? I'm kind of keeping it in general terms. Can anybody throw that out there?
But is it the null has no significant difference between the variables?
That's another way of saying it. Significant difference. Okay, but we really just stay with difference. If you said significant difference and significant difference or no significant, those two things, okay, or non-significant difference, those are both the same words. But let's just stay with difference. How do you find the difference? Let me change that. How do we find the difference to choose like the null or the alternative? What are we looking at?
The p-value?
Perfect. Is that you, Rachel?
Yes.
Perfect, Rachel. And why do we look at that? What does it tell us? Kind of already gave you the answer.
If there's a statistical difference or not.
Significance or non-significance? Is it above 0.05 or below 0.05? So you're never going to know the impact or the effect. All you're looking at is when we look at the data, is that number above 0.05 or below 0.05? And then we choose either the null, we either accept the null or we reject the null. I'm sorry, reject the null or accept the alternative.
So is it if the p-value is greater than 0.05, you can reject the null hypothesis?
Yes. Trying to pick my brain now. It's been a long day, sorry. Just like for everybody. Come on, be smaller.
I'm sorry, I misspoke. If it's the if the p-value is less than 0.05, there would be sufficient evidence to reject the null hypothesis?
Yes, is less or equal to, yes, 2.05. Correct. So taking that p-value, which we normally keep at 0.05.
Can the
Go ahead.
no,
Go ahead,
that was my question is the p-value, will it always be 0.05 or can it be less than or greater than that?
It's usually not greater than that. It can be. It's really up to the researcher and what they're looking for, at what level they want to take it at. So it's 95% confidence interval means there's 5% chance that it's done by chance.
Can the p-value ever be 0?
No, not in terms of what we're talking about right now. It would generally be 0.00001 or something like that. It's usually got a couple zeros and a 1. It can go from there all the way up to 0.05. I have seen people that put it at 10, but a lot of that comes from a different country like Europe or something like that. We really stay with a 0.05, 95%. And most of the stuff you're going to do educational in class is generally going to be consistent with 0.05. That kind of makes sense? So your p-value is looking at how much chance there is that this is right or wrong. That's why I said at the very beginning that statistics is not really math. You are looking at a probability of something being correct, because understand you cannot run all the tests that we're going to run in a week or two, starting a week or two. You never get the whole picture. So if you run a one sample t-test, you get an answer. There's confounding variables on the outside that can change that. Same thing if you do anything, especially when you're looking at, let's say, a correlation. You're looking at these two independent variables, but it's not that. It's the idea that I could say, I always tell the story of, and unfortunately, all my stories go to a guy and a girl. But if you look at a relationship starts out, it's wonderful. You got a perfect relationship. That would be ones on either end because you have the same power. Okay. As we go along, you find out my idiosyncrasies, you find out my things. All of a sudden, I go from a high correlation to a low correlation. And then when we break up, there's no correlation. Okay. All that is a periodic movement between our relationship that does not count for anything else, such as, let's say, somebody cheating or somebody their girlfriends or their guy friends are talking bad about the other person. Those are things that are involved. So that's why 95% is always a good number. You got 5% chance, but it's a standard in social science and mostly in science. When you get into some drug testing, they take it lower. Experimental may take it lower, but that's really the only place, because most people that read it understand the 0.5. That is the easiest way of doing all of this. There is another way, which I'm not going to show you. Basically, you get the DF and you get the 0.05, and you go across and you look at the t value, or you look at something else. And I'll be showing that a little bit when we get to that, but I don't want to get too into that. There's multiple ways. There's one visual, and there's one just, hey, this is this, we're picking the null. This is this, we're picking the alternative. But remember, you're never getting a real conclusion because you don't have all the data in any one test. You'd have to run a ton of tests, but each one comes up with a conclusion, regardless if the null is accepted or the alternative, but you're looking at a difference, not an effect. So if there's, and think of it this way, it's so simplistic that no difference means it equals. And there's a difference, it doesn't equal. Period. So in most textbooks, they will give you, they'll give you an example of let's say a bolt factory. And they're running the bolts on X number. They're looking at X number of bolts to see if there's a difference in any of the bolts. So one is there'll be a difference. There will be no difference in the bolts of let's say size of let's say an eighth of an inch. And then they'll do the alternative, where there'll be a difference in other bolts of an eighth of an inch. That's a really big, but I'm giving it for an example. And then when the test is run and they look at each of the bolts and they measure them out, they put them on a big list, they run the data, boom, every one of them was perfect and perfectly in line. Then you're going to take the null. There's no difference, equal. If you got a whole bunch of different numbers, you got a difference. So you take the alternative. And all it is a statement. It kind of dies. It kind of dies. It tells you the direction of your data. And then there's a conclusion, which we would say that if, let's say there was, I'm just going to use that, there was no difference in the size of the bolts, meaning that the manufacturer has a well-used equipment that's doing the job. And I just kind of make that up. It's not very scholarly, but hopefully that kind of gives you an idea that it's just a statement that you're saying, this is what we're looking at. It's an added to a research question, which you may not have a research question. You may just have a null and alternative. So you have a purpose statement, and you always have a purpose statement, just like in English or anything else. but now you've added to it either a research question of what you're really looking for, and then you do a hypothesis, and you could have multiple hypotheses. You can have multiple null and multiple alternatives based on whatever you need if you're looking at multiple things, like if you're looking at a couple things. So you're really looking at a paired sample t-test where you're going to have a hypothesis that there's either going to be a difference or there's no difference. Okay, and that's what's real important. So those of you that did not do it right, you need to go back and change it. There should be a difference or a no difference, because you can't measure in a hypothesis an impact. The data that you're going to run is not going to tell you that. All it's going to tell you is a difference all throughout all of your data. Now, you can go to some articles where they write impact. They might, there would be equal impact, or there would be a difference in the impact. And that's the way most of them are written. Now, if you go to a different country or you go to something else, you might see something differently. Everybody writes them differently. And I can tell you that different textbooks will tell you to write things differently, especially when you're doing your data. I can have two textbooks sitting next to me say the same thing. They just write it differently. Your textbook writes it differently than I normally write it. Okay. Same thing. It's just a different way of doing it. So don't be locked into anything. But the real keywords are difference, because you're going to be looking at all the tests that you're going to be running. You're going to be looking at difference. Even a one sample t-test, you're going to be looking at the difference. Is it above or below? You're independent. You got like male versus female. Is there a difference between male or female? Now, how does that work? You got two. You're only going to have one null and one alternative, but the data will pump out a number that gives you a p-value, and then you're making a decision on the whole. So once you leave your one sample t-test and you move in the other ones, you're looking at different amounts of variables. It's still going to give you, in a lot of cases, one p-value. And that p-value is from everything. It's going to tell you if there's a difference between all, or tell that there's going to be a difference in one or two or three, or if you're looking at one versus three, there's lots of different ways. Okay. But that p-value tells you what you're actually looking for when you get that data and what that p-value is. Does that p-value go up above 0.05 or below 0.05? And then we make the decision on the null, and then we just report it. There's no analysis after that. Your analysis after that goes to the basics of your whatever test that you're running. Okay. Are there any questions on that? It's like silence is being, there are no questions. It's truly abstract, and for some people you picked up on it really quick, and some people it takes a long time, and I'm one of those people. It took me a long time to visually see it in my brain of what the necessity of writing a hypothesis is when doing a research question. Kind of does the same thing. It just doesn't point to a difference or a no difference. If you were doing a qualitative study, you would not have a hypothesis. There's like 2 articles out there now that say that you should have an alternative, that there will be a difference. Well, when you're doing qualitative, you're always going to come up with a difference, because there is no way that you can take 10 to 15 people and have them say exactly the same thing. So you're going to accept the alternative regardless of whatever it is. So there's no use, and your research question is really strongly driven toward that's what you're going to answer. You're not really asking of a difference. I've done probably 60 or 70 qualitative studies, including my dissertation. And there was like 2 people that said pretty much the same thing. And they were taught by the same person. Their mentor was the same person. On the other ones, a lot of them, nobody said the same thing. Because that's what you really want. You really want to have diversity in there, and that's what you're within whatever level of participants you're giving. Now, what you're going to be using is probably a set of individuals that may have the same characteristics, but they're maybe going through something in different levels. And if you're looking at something like a paired sample t-test, it's generally a pre-test, intervention, and a post-test. Now, it could go pre-test, intervention, another test, intervention, test. There's lots of ways of doing that. But in most cases, a pre-test of whatever it is, whatever you're measuring or whatever you're doing, and then there's an intervention. Let it be a drug, let it be a therapy session, whatever it is. And then you have the post. And then when you run your data, you get a pre-test and a post-test number. One's going to be higher than the other. Now, what happens if they both equal? Well, guess what? You probably got a null hypothesis there because your p-value is really going to show that. Okay. Now you take that, and then what you do is you say, well, the pre-test said this and the post-test was higher. What does that mean? That my intervention worked. Okay. The greatest ones are always, I have an English score. I gave you all the statistics test, the pre-test, and then at the end I gave you the same post-test. During this 16 weeks, I gave you an intervention. I'm praying that score is higher. Okay, but what if it's not? Well, then I have to go back and look at what my intervention was. What was my intervention good? And then I have to put it in mind of, be it that I have I've got a demographic sheet on you. This is the fourth time you've taken statistics and you bombed them all. Well, you have a different mindset that somebody has taken it the first time. So all of these factors come into there, but when you go back to the null, it goes back just to the answer of your data and that p-value. So I think I have basically beaten this dead horse, but if you still need more, let's stay after, ask your questions. I'll work you through it and you'll be fine. Okay. So those of you that didn't really get it, it's a difference. Okay. Not an impact, not an effect. Okay. It could be said that there is no difference in the effect of whatever it is, but that difference and no difference has to be there. Now, if you want to say significant difference, non-significant difference, hey, you're good with that one too. But really, you really just want to use difference, because the idea here is that's when you say, if I add more words and I put it in the wrong place, I'm basically blown it. So everything should be in simplistic wording, not fancy dancy anything else, because once you do that, you open yourself up to interpretation. So when it comes up to saying there's a non-significant difference, that means that it was below 0.05. But we're really not looking at that when we're looking at a hypothesis. I wouldn't mark you down, but I really don't want that. It's just the word difference, because what you're allowing to do is allowing the data to speak back to that. You're not pinpointing anything. You're allowing it to be neutral. Difference, no difference, period. It's one of those things that when I'm going to probably say this every week, don't add to the conversation. Say what you mean and mean what you say. It's the idea of, you're going to do a paired sample t-test, and let's say the men are higher than the women. You say that the men are higher than the women. Just like that, whatever's in your head, in a general, straightforward sense, because then it's easy for everybody to understand. If that number is below 0.05, we are going to take the null or the alternative and vice versa. But that's a sentence that leads into the factor of your conclusion. It's part of your conclusion. In essence, so when I write it, we don't even talk about the null, because if we talk about the sense there was a non-significant difference, it's automatically known that we went back to that and picked either the null or alternative based on what the answer is. I would imagine in yours, you're going to have to say, due to the factor that the p-value was this, we're either rejecting the null or accepting the alternative. And then ends. There's no more clarification. It's straightforward. Okay? Stands on its own. Okay. Moving on, because that took too long. I rambled. Oh, there's a question. I will do the best I can. It's not up to me on getting the video. It is up to Zoom when it gives it to me. Last week, I was a little bit late, but it didn't come in till the next morning. And then I don't know what happened to me. Probably busy. But I will try to get it up within the next 12 to 14 hours. Okay. The other half, G power. Sharing my screen. Where are you? Where is it? There it is, right there. Okay, we're in the module now. I don't know why that's so small. It's a little better. Week 7, p-value, sample size. Anybody have any questions on what we have here? So I'm going to run through real quick. The p-value is, there's a formula for it. I'm not going through it. We can find that p-value. As long as we know what we're doing with that p-value, that's more important than whether you that's why I don't like doing the formulas. You can spend all week doing the formulas and get the wrong answer and you get an F. It's not. With everything is there. I look at what you're doing, even using Excel, okay, is going back to my young days, and there may be somebody else in the room that's my age, where the first calculator was the long one from Texas Instruments and had little red things, and it did thing. You could add, subtract, multiply, divide, and a few other things, and you can turn it over and say, hello. You can write out the words hello out of numbers, okay? That's all it could do. Well, we have programs that do all the formulas for us. That's what my mentality is that you should know how to do that. But in the same respect, what it does is it gives you the correct numbers to be able to analyze at a high level, critical thinking. And that's part of what your DNP is for, is critical thinking. So do you have to know everything? If you're one of those people, you got to slow down when it comes to stats, because if you try to know everything, you spend hours and hours getting one thing done and then get nothing done. Your p-value does one thing, and that is it gives you a number that allows you to pick between a null and alternative. Keep it simple, soldier. Okay. Your sample size is really important. Okay. So in basic statistics, the number 30 is the key. So you have 30 people that you surveyed. It's the minimum number. It's actually more like a pilot study. I think your book might talk about it a little bit, but a pilot study, when you do a dissertation or even the DNP, you're not going to have to, but a lot of places make you do a pilot study first if you're writing your own thing, because then you can do have to do it twice, pre and a post, and then you have to run a correlation on the questions, and it has to come out where they have they are significant to each other. The correlation number means that they're very highly correlated. Okay, so your sample size. If you're doing a qualitative, you need 10 to 15, because if you try, I got somebody that I was working with that their mentor wanted them to do 300 interviews. Yeah, it would take you years to go through all the data. So in terms of keeping it simple, you can't look at everything. In your DNP, you're going to pick a topic and you're going to want to learn. You want to do everything and know everything. No, in your lit review, you're focusing heavily on learning as much as you can. But when you come to do your data, now you're talking about a sliver. So in most of your cases, when you go to your DNP, that sample size is important, but it's also the inclusion criteria that you're looking at. So if you're doing a study on diabetes, well, you can't do studies on diabetes with non-diabetic people. Okay. It just doesn't work. You're not going to get the answers. If you're looking at an athlete and how an athlete handles stress, if they're not an athlete, they can't answer the questions on athletic stress. So your people are going to end up, your participants are going to end up being somebody that has value. If you do the value and you get the value, guess what? Life is really easy. You get your answers that you need, and then you can dive deeper and beyond it. Okay. What is the significance wording for a p-value? I like whoever I said the other one. What is it above point? What's the words that I'm looking for? Above 0.05 and below 0.05. How does G power help you to calculate? Okay, I'm not going to give you the answers, but it does have to do with one of the questions earlier. Explain confidence level, explain effect size. What does it mean to have a 95% confidence level? What is an 80% confidence level? Okay, kind of gave you a little of those answers before. G power. Okay, this is one of the ones that it's just like when I did my very first write-ups in my master's thesis. I thought, this is crazy. This can't be the way it is. I had the same problem, and some of you may have the same problem when you went to do this. Why is he making us do this? I'm making you do this because you need to know this, because you're probably going to have to use this program when you get to your DNP. How do I know that? Dr. Kim said, hey, they need to know G power. It makes it real simple. Okay. G power does a lot of things, but really that a priori is what you're looking at, because you're looking at sample size given power. Now, my study that I ran the G power on, I was supposed to have 4 participants. Okay. And I'm sorry, I was supposed to have 15 participants, and I had 30. You can go above that number. Now, here's the caveat to a sample size when you're doing studies. You cannot go and do 1,000 people without doing G power. Okay. You have to run G power or something like that. Or if you got somebody that knows how to do it in Excel or whatever. And the reason why is because if you throw that sample size real high, you will not get, the power will drop. So I want to talk about the boxes real quick. Okay. And if you messed around in there a little bit, you saw them. The test family itself is what kind of test you're running. And when you hit that, it'll give you the list, as you saw, it'll give you a list of what to pick. And you just have to pick the right one based on there. Can't go into all of them. We'd be here till 9 o'clock. Okay. The a priori is what you want. There's other ones in there, and I'm not going into them, but they do different things. But this is the one where you're looking to get your sample size using a power in that. Now, this determine button over here is if you already know the mean and standard deviation, you put that in there and it does all the rest of the work for you in the backside. But most of the time, you're already going to know it. There's a one-tailed test and a two-tailed test. 9 times out of 10, you're going to be using the two-tailed test. The effect size is the effect size DZ. You can see that it's 0.05. The effect size is either 3, 0, 3, and 5, but you can click on that and it will give you certain numbers, or 3, 5, and 7. They're different for each of the tests, but the 3 means it's low, 5 means it's moderate, and 7 means it's high. You can change it. And basically, once you've got everything in there, you can change the effect size and it will change your sample size. Okay. The alpha error probability is 0.05. That is the same as the p-value we're looking for. It's the same thing. P and alpha are the same thing. That means there's a 95% confidence level. Okay. Now the power, 1 minus beta. Okay. Period. It's either going to be, generally speaking, it's going to be 80% or 95%. It gives you the same numbers backwards. So when you're doing the significance level, 0.05, 95% confidence level. We have the 95 there. We have 5% left over for chance. We have 80, it's 20%. And most of the time it's going to be 80 because you want that lower power, because then your sample size, if it's above or below, you're still going to be fine. So if you already done this, you plug in those numbers, you put in a 95 or an 80 in there, and you make sure everything is there. because the test that you're being asked to run is in the t-test family. Okay. And then what you do is you press the get that in there, press the button, and it gives you the sample size right here. We're not going to talk about DF today, but basically the sample size that you need. And then all you do is you're going to run it at put 95 in a box and then put 80 in the box. And you want to make sure you don't do anything else. And then you just highlight those two and put them in there. It's the idea that you've got the answers, not what the answers are or anything else. You should look at the sample size. But if you play around a little bit with it and you change that effect size DZ to 3, you're going to see the sample size change. Well, generally 5 is moderate. That's what generally the base we look at. And then if we want to look and see if we believe that we really want to go for an effect size of 3, which is low, which doesn't really help us, or effect size that's high, then we're going to do that. So our sample size will meet that 80% or that 95% based on what numbers they are. So you want it on protocol of analysis. If you go to the central and non-central, you'll see the normal curves and see where it crosses. Okay. Tells you tells you a lot about the chance of making sure that you get that 80%. Okay. But this is the one where you just need to know it. Now you've got it on your computer. If you had to do it, if Dr. Kim says, hey, we need to do this, you know where to plug in the numbers and you're ready to go. And I just checked her work on a paper she's working on, and I used the same program. But it was a different test, so I had to figure out which test it was. And then once I found out the test, I came up with the number, and I was really close. So my number was 110, 100, and mine was 110. She said 118. So that doesn't mean that's the exact number. That's for total minimum number it says total, but minimum number, you don't want to go below that. Okay. Any questions on that? And then the p-value is to the hundreds place. Okay. That's about it.
Are
Any
you going to
questions?
go over how to get the p-value? Because I ran the test like 2 or 3 times, and I would literally get
In this
different
short video,
data.
You do that's how I found out how to do it.
Sorry, what did you say?
I just used the video.
The video just tells you how to download
Oh, it does, doesn't it?
the add-ins. It doesn't tell you how to get the p-value. I just did my own research. But when I used the formula, like I ran it a few times, and I would literally get different answers each time for the same data that I inputted.
I did the same thing, and I found multiple different YouTube videos on doing the p-value with the data analysis tool pack, and I did the same thing. And then some of my p-values were like 1.988, which didn't make sense.
Yeah, that doesn't make sense.
Yeah, I did it too, and my p-value came out to one of them came out to 0.00.
That's good. That's a number.
It might be, I was like looking at it, it might be the way that the data is
Why is that
organized in
answer
the
there?
column. I think it's like randomly assorted, and every time you enter data, things are like changing in the number assortment, and that's affecting the answer. Does that make sense?
Lovely. Same thing as that would be the same thing as the homework. So my question is, did you get this?
Yes, I got a table like
Get
that.
that? Okay.
Yeah, and that
Everybody got this? Was something that looks just like this?
Yes.
Yeah.
Great. Put in the numbers, whatever it is.
Okay. Do
Okay.
you just want the p-value, or do you want us to put in
Just
the
the
whole
two-tailed
table that we
p-value.
did?
Just a
Okay.
two-tail p-value. Just put it in there. I'm not going to stress on it because if you got to this point, you understood the assignment.
Okay.
Yeah, I think I had this. You had the same problems as I had, and I don't know why. It's like out of the blue, something funky that I put in all those numbers and then I went and I did it again and the numbers changed. I'm like, how are the numbers changing? I put the numbers in there. I just tried not to get duplicates and I didn't do a very good job at that either.
So
So
even if like mine for the two-tail p-value right now is
I'm not going to stress.
okay.
We got more things to worry about than that. We got more things to worry about than the number being wrong. So if you, some of you are going to end up with 0, 0, 0, and some of you are going to end up with somewhere else. If you got the number that it came out of Excel and you just didn't make it up out of the blue, you could make it up out of the blue, and I wouldn't know the difference because I have 0, 0, 0, and I don't know why that's on there because there's the answer. But regardless, if you ended up with that, then you know how to run it. And some of these things, it's all about like this. It's you know how to run it to get the p-value. Then when we go to the real data, we start breaking down our real data, it'll make more sense. So if you got something that looked like that, then you did everything correct. It's the numbers that are funky in Excel, which wouldn't happen in the SPSS. Everybody clear on that? I'm not going to stress on that answer. Get everything else right, and we're good. I hate to do that, but I mean to go back and try and figure out the week could be over and we have to move on to the next week. So as long as you came up with that box, then you're good because then you know how to run that to get that box, and you're going to be doing that again anyways. So I'm not stressed on that. Everybody like that one?
Yes.
We won't have this problem next time. So, any other questions?
I do have questions.
Shoot.
I'm still a little bit confused on the discussion. When you assign the
Okay.
numbers, like you
Which-
assign me the numbers like 26, 8, and 13, and then we go choose the interventions or the discussion number 7, not that one.
Oh, hold on. I'll go back.
Mhm.
Okay. Does anybody else have any questions while I'm pulling this up?
Mine was similar, like on that thing, it says like formatting is super important, but there isn't like the video tells you like pick your name and it gives you the numbers and then you write a null and an alternative, but it doesn't show you like formatting or anything like that.
Actually, it did. The video did.
The video, I think, just showed the table, like
Yeah.
you assigned like our names and the numbers.
No.
And that's it.
The video in the overview. Did you go to overview and watch some of those videos?
I did. I only saw a video that was posted from Professor Lori Ballantyne, and she talks about a lot about.
Hold on.
Yeah, that's why it was
You see
confused.
these? You see this, right? This is your title. Okay.
Yes.
Now, if I go back, let's go back in time here. I don't think it's in discussions. Let me go back here. Modules. And then I go to week 7 overview. And I slide down here. We got tons of videos.
Yes, but none of them explained how to format it.
It's either HO or H1. HO is your null and H1 is your alternative. And then you put an equal sign and you put your null hypothesis and your alternative. I so need to buy.
There it is. There's my pressure point. This is really important. This is a field cue, but it's really good because you don't have to look for it.
Right. In this
See it right here?
I want to show you the basics of
HO,
hypothesis
H1
testing for
Okay.
the
This is not
non-traditional.
the one I did. So when you write up your null,
Right, in this
when you're
video,
writing up your
I
null,
will
you
show
shouldn't be
you
writing
the
null. You should be writing
hypothesis
H with a
testing
subscript
for
subscript
the
O and a
non-traditional
H1
method
for your
of
alternative with a
p-value method, be more
like this.
specific,
So
the
if
p-value
I
method.
you stop
I have
talking. If I take word here, I go big H. I didn't want that. I want H, please. H, and then I put a O, a 0. Highlight the 0. And then I do this little X right here, right underneath the number generally. And then what I have to do is then I have to turn it off. And then I do space equals. Is that an equal? Equals. And then my null goes here. You don't write the null hypothesis. There will be no difference, blah, 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 blah. Then I do the same thing down here, except now I go H1 and I drop it here. And I make a subscript and then I do a space. Anytime you do equal sign in equal anything like that, there's a space between them. They don't like anybody else. And then you write your alternative, which would be there will be a difference in blah, 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 blah. Does that make sense now?
So based on the number that we got in the sentence that it says evaluating the effectiveness of resiliency training programs in the reducing burnout among nurses, we just have to come up with something that will work out, like an intervention.
You already have everything's right in front of you. You're not doing an intervention. You're writing a null hypothesis. There will be no difference in what? Tell me.
There will be no difference in the resiliency training, like the effectiveness
What
of
else is in that sentence? Okay,
reducing burnout.
this is where you have to learn about keywords. There are keywords in that sentence, in that title that you were given, that you are studying. So what are the keywords in that sentence? A keyword is something that has meaning that if you took it out, the sentence would die. So what words in that sentence?
The burnout
Okay.
and the resiliency training.
Okay. Did it say what who the participants were?
Nurses.
There you go. There will be no difference in burnout as it relates to resiliency training for nurses. Simple. You're taking the words and now putting it in there. That's exactly what you're looking at. Burnout, resilience training, and in nurses. And he's going to say there's going to be no difference. So what would the alternative be?
That's gonna be a difference
In what?
in the in reducing burnout due to the resiliency and training.
Okay. That's it. One has no difference, the other one has a difference. This is why you're doing it 3 times. You gotta do it repetitiously to know that what are you studying and there's no difference. What are you studying and there's a difference. And all of them start the same. There was no difference in burnout. Let's say I'm making this up after resiliency training for nurses. There was a difference in burnout as it relates to a resiliency training for nurses. Sentences are both the same. It's just the one's a difference and one's a no difference.
Okay, now it makes sense.
I was overthinking it too, Grace. I was thinking the same thing.
Man,
but
so did I.
Then it was like, okay, it's either difference or no difference.
Yeah, like I
I
said,
think
some things are so simple that we complicated. I'm going to tell you, that I beat this one to death until my tutor in advanced statistics said, yo, just make it simple. What's the topic? Is there a difference? And one's a no difference. And I went, oh, and then the light bulb came on. It was just too easy. And some of the things you're going to do are really easy, and we're going to make it really difficult until you figure out everything's really easy in terms, not easy in terms of getting there, but when you're talking about it, it's really simplistic because you're laying it out. Now, you could do a lot of journal articles and get some really, really technical ones where there super duper doctoral awards in there that, that mean something else. But what you do is you open yourself for interpretation. So you don't want to say, well, there's the null hypothesis. Okay, I'm a scholar. I see HO. I know it's a null. If I see H1, and it could be H1 and A, depending on where you're at or what you wanted to use, but it's still the same. And that's why I like using HO, because 0 correlates to the words no difference. So it was just like a kind of idea. But I beat it up and I tried to make it real difficult. And she said, just say this and then do this. And I went, oh, is that easy? And after that, man, I just banged them out left and right. It was so easy. It was so easy. But it's like I said, practice. So did I get that one? Any other questions?
I think the formatting just threw me off.
Yeah, it does. And I thought there was a video in there that talked about the null and alternative and showed it in the right format. That's why.
Well, I watched that video, so I understood that part. I just didn't know what to do with that sentence, and I thought we had to make something up. And I was like, okay,
No. Oh my gosh, trying to make something up. And I wonder I'd be pulling my hair out. I don't have any hair.
Well, that's why I was pulling my hair out.
So, but the question would be why didn't you text me?
Because I knew we was going to have Zoom meeting tonight, so I just waited.
Text me earlier. If it's that much stress, just text. It's not a big deal. Okay. Any other questions?
No, but Dr. Jeff, this is Sean and Bond. I have no idea why my login says that. I don't know where that came from.
For what?
You see what my login says? Dumb beach.
I have no idea either. I thought it was pretty cute.
I have no idea why it says that. It should say, I don't know where that's coming from. I got to fix that somewhere.
You have children?
I do.
Good. That's probably where it came from. They changed their name.
Oh, okay. I have to fix that. Okay.
That's one theory. I know that I can't. My son got my phone and changed my nickname, and I didn't know it for a long time. And somebody finally said something. I said, "What are you talking about?" He said, "Look, this is what your text message comes across as." It wasn't bad, but I mean, it was just a little bit off of my name. But I talked to him. He started laughing. So yeah. So I don't know how you fix that, but I'll do a little research and see if I can find out how.
You can change it if you open under the participants. If you click on that, you click on your name and you're able to rename it.
Ah,
Let's see.
Good looking.
Okay, I'm gonna try to fix it now because I don't like that.
Yeah. Oh yeah, right there in the third one says rename. Okay. Thank you. For whoever said that, that's awesome. That's something.
Thank you, Grace.
Not a good teamwork makes the dream work. All right. If there aren't any questions, you're welcome to go. If you still have more questions or need to talk to me, feel free to stay, and I'll wait until everybody's done. Sorry it took an hour tonight, but it's that. Next week will be more of we'll be talking about validity and reliability. So it's kind of a kind of smooth week. No Excel, no nothing. Just understanding that concept. Okay. If you don't have any questions, you're free to go. Otherwise, stay and hang out and ask the questions. And you can start anytime. First one up wants to talk.
Oh, I wanted to confirm these, the p-value sample size assignment.
Talking about G-Power?
Yeah, the both of the assignments for this week are both discussion posts. Is that
Right.
correct?
It's discussion about you're supposed to be helping each other out.
Okay,
Now that we've had the class, might make more sense.
okay.
Anybody else have any questions?
I don't, I'm just trying to fix my name. So y'all can log off whenever my computer's just running slow.
Did you find it?
No, I opened up
What do you want your name to
participants.
be?
Just my name, Shannon Bond. I just can't fix it.
CH
CHAUNON.
U. Okay. Okay. Do that again. CHAUNON.
Uh-huh.
Bond.
Yes, like James Bond.
James Bond. That's just what I was going to say. Bond. James Bond. There you go.
Thank you.
So
Thank you so much.
If it comes up again next week, holler right at the beginning and I'll just go in and fix it for you.
Okay, thank you. I appreciate it.
Said that I went, uh-oh. And that's the first thing I said was, I bet you her kids got to her somehow.
Yeah, but it didn't register until I kept saying, who is DB? And I was waiting. I was like, but that's me. And I was like trying to figure out why it kept coming up that way. So
I've had lots of crazy. I got one that calls herself Puffball. So,
oh my gosh.
Thank goodness I know her. Thank goodness I know her name.
Right. Well, thank you, Dr. Jeff. I'm a do my assignment now.
Keep asking questions. You're all good.
Well, thanks, Dr. Jeff.
Yes.
Bye.
Bye. Have a good night.
Bye. Have a great night. Bye. Mm-hmm.